What can this Highland Games competitor teach us about tilt pad bearing design? This is the first video in a series from TRI Transmission and Bearing Corporation. We will be comparing two bearings, explaining why some design features are the cause of ongoing maintenance problems. When our competitor lifts this heavy load, he uses two hands positioned at the bottom of the rock. He's not lifting one-handed or with his hands to the side. A bearing that supports a heavy load with tilt pads can benefit from this simple observation. Here are three bearing designs. They all have equally spaced tilt pads. The 6-pad bearing supports 100% of the vertical load on one pad. This design is analogous to lifting a heavy rock with one hand. The 4-pad and 5-pad bearings both share the rotor weight between two pads, like lifting a rock with two hands. When you employ a little trigonometry, you calculate that the load on the lower pads in the 4-pad bearing is 71% of the vertical load. With a reduced angle from the vertical center line, the lower pads in the 5-pad bearing carry 62% of the vertical load. So, the pads in the 5-pad bearing are seeing the lowest forces from the rotor weight. This is important because high forces reduce the oil film that supports the shaft. The reduced oil film leads to more shearing and more heat. Bearings that are overloaded get too hot. Maybe we can rotate the lower pads in the 4-pad bearing to the same location as the 5-pad bearing. If you did this, the lower pads in the 4-pad bearing would also carry 62% of the vertical load, but you opened up the bearing clearance area. To visualize the bearing clearance area, move the rotor around in the bearing assembly. As the rotor moves, mark where the center of the rotor is. A shape will form at the limit of the movement. This is the bearing clearance area. Because the pads tilt, the most movement is going to occur between the pads. The amount that the rotor can move from the center of the bearing increases when the gaps between the pads increases, so the maximum deviation of the shaft center line is minimized when the pads are equally spaced. And when you compare the three designs, the bearing clearance area for the 4-pad bearing is larger than the others. If the lower pads of the 4-pad bearing are moved to 36 degrees, the bearing clearance area gets larger, and it doesn't help if you make the pads bigger. The pads just tilt out of the way. Since the bearing clearance area of the 6-pad design is less than that of the 5-pad design, can you rotate pads to share the load for the 6-pad design? Not really. First of all, that would put the pivots at the horizontal joint. Even if you could get by that design challenge, there is a bigger problem. The pads that are now on the side won't fit over the rotor at assembly time. The distance across the edges of the pads is less than the diameter of the rotor. So, from this brief analysis, we can determine that a heavy load is best supported by a 5-pad bearing. In our next video, we will look at preloading.